In the last video, we learned about truth tables and a little bit of negations and what it means to have an and or an or statement. So in this video, we're just going to do a little bit of practice with all of these topics, starting with constructing truth tables for all of these, where you see a tilde that's kind of inside of the number or inside of the letter. That's my fault. I don't know why the tildes are not coming out well in these presentations. But take a minute and see if you can build the truth tables for these without my help, without me going through them. You can pause the video and try to do them. So, we are going to construct a truth table for not P or Q first. Not P or Q. And our truth table starts always with P and Q. And we have true, true, false, false. This is how you always start a truth table. True, false, true, false. Those are all the possible combinations of true and false in two sets. And now this time, just like how when we were doing set theory, we had to figure out what a complement was. Now we have these negations. We have to figure out what that is. So if P is this order of letters, then not P is just going to be the opposite. So where there's a true for P, we're going to put a false. Where there's a false for P, we're going to put a true. And that is not P. And then we have not P or Q. So now that we have both pieces, we can write the whole statement, not P or Q. And remember, an or statement, when you have the or statement, this is true as long as one piece is true. True as long as one simple statement is true. I'll just write SS for simple statement. So, we're looking at the two columns, not P and Q. So we're looking at these two columns, the ones in between the red lines. And we need at least one of them to be true for it to be true, otherwise it's false. So the first one, we have Q is true. The second one, they're both false, so we have a false. The third one, they're both true, so we have a true. And in the fourth one, we have not P is true, so we have a true, since we have a T right here. And that's how you do a truth table when you have some negations involved. So now we'll do the second one. In fact, one good thing about these truth tables is that you can always continue using the table you have. So with the second one, this time we need our not Q. We need not Q. And not Q is going to be the opposite of Q. And the opposite of Q here is going to be false, true, false, true. Because Q is true, false, true, false. So now we can do our P or not Q. And remember, P or not Q is just going to be us looking at the columns for P and the columns for not Q. And as long as one of them is true, we get a true. So in this case, the P is true. In the second row, both are true, so we get a true. In the third row, both are false, so that's where we get our false. And then in the fourth row, one is false, one is true, so we get a true. And then we can do the same thing for, I'll bring it down here, not P and Q. Well, the values for not P and Q, this last one, we have to address not P, which is right here, and Q, which is right here. And remember, an and statement is only true when both pieces are true. So the first piece, where we have not P, is false, so we have a false. Then they're both false, so we have something that's really false. Then we have true, true, so we get a true there. And then in the last piece, we have a false, true, which is going to be false because we have at least one false, and this is an and statement. And these truth tables can be a little confusing when you're first learning them. So my suggestion would be to definitely do the bookwork, definitely complete a few truth tables on your own, redo the problems in the videos, and then rewatch the part of the video where I go through a truth table. It'll make it a lot easier to complete. So for a little bit more practice, let's write these in words. Let's write these scenarios in words. If P is I have a penny and Q is I have a quarter, then not P is I don't have a penny. I don't have a penny. And I have a quarter. In the second case, we have P, which is I have a penny. And I don't have a quarter. And then in the last case, we have I have a penny. I have a penny, or I don't have a quarter. Just translating these directly into words from their simple statements. Moving on. What if we want to write these in symbolic logic, these statements here? Well, we would start by writing what is P and what is Q. So P is going to be, it's going to come from this one. It is not raining in Philly, so for P, we're just going to write it is raining in Philly. In Philly. And then Q is going to come from here. I am going to the zoo. Well, that's fine, so we'll just write it. Q is I am going to the zoo. So now writing it in symbolic logic, we have this is P and this is Q. Well, they come from those. I'll erase that so to avoid confusion. It is not raining in Philly is going to be not P. So we have not P. And then we have an and. Remember what and is. And is the caret symbol. And then we have Q. I am going to the zoo. So we just have a Q. And then underneath we have it is raining, or I am not going to the zoo in Philly today. So it is raining, so we have P, or I am not going to the zoo in Philly today is going to be not Q. And now just a test to make sure you guys are paying attention to my videos. Use the same statements. We'll say P is equal to R and Q is equal to Z. Use the same statements and write those as sentences. Write these as sentences. Put them back into sentences from the symbolic logic that's written. And if you do that and send it to me, you get an extra credit point on the first test.